All right, my name is Stefanie Mueller. I'm an associate professor in ECS and joined with MECE. And I tell you, my original plan was to show you some of the most recent work in our lab, but then my toddler got sick, all my childcare fell through, so I'm going to show you a highlight of our work that some of you may have seen, but I hope it's still new to some of the other folks. Oh, we still have a little jiggle wiggle here? What's going on? It does not look too promising. Say it again. Ah. Nope. I just get going. All right, we have a little jitter. That is okay. Cool. All right. So let me just get going. You know, I'm a big fan of just getting in there. So computing has changed a lot of things, how we do a lot of things today, right? I'm sure everybody has their own examples. I will give you one from product design because that's an area where my lab does a lot of research in. So let's say if you're designing a car these days, right, it's actually really easy, right? You have a 3D editor, you can create a model of a car, and if you want to change the color of the car, you do like one click, and you can make it yellow or blue or apply a certain texture pattern. So now I'm sure if you would do the same in physical, that is actually not so easy, right? So let's say if you wanted to recolor your car, right, you would have to go to a garage. It would cost a lot of money. They would take your car away for like a day or two because it also has to, you know, dry and they have to paint it and it takes a lot of effort. So in physical, things are still hard, right? Versus in digital, very easy these days. So a focus of my research lab, and this is, I will give you one example of this work today, is how can we actually give like physical objects the same capabilities as we have in digital already? So that in physical, we could, for instance, recolor the car in the same quick and easy way as we can already do this in digital. So this will not be required anymore. We will just have a little mouse, click, and your car will look different. So the example I'm going to give you today is work we are doing in reprogrammable appearances. And I'm just going to play the video. So we have this smart material that we developed that you can spray onto any object. And then if you shine some light on it, actually from just a normal office projector like you have here in the room, we can reprogram the appearance. So after you reprogram it, we can also fully erase it again, and you can choose a new color texture you want to apply and reprogram the object again. So it's fully reversible. So you saw the chameleon, as you know, the standard color-changing object that we all know. You can do this on phone cases. We have done this on shoes, so you can totally do it for fashion as well. And as you will see now, we have also done it on cars. This is not a full car. It's actually a really small car model just for demo purposes, but you can imagine how this would work on a big car as well. All right, so we have different like company collaborations. I will not spoil the names here because some of this is confidential, but we have worked with industry on this as well. So just to show you the images again, this is the same phone case. So literally if you had your phone case, this is the same phone case and all the images with different textures. This is the same shoe. You can see on the top we have more like a wavy pattern. On the bottom we have some stars. And this is the car. Here in this case, we only recolor the car door for demo purposes. So you can see it still takes like 20 to 30 minutes per site at the moment for a full color texture transfer. So it's not quite instant as in digital, but it is definitely faster than getting your car into a garage. And I will tell you more about it, how it works in a second. We have some other ambitions, maybe for clothing, right? So these are just some images from the internet. We haven't done it yet, but obviously it would be really cool if you could change the color and texture of your clothing every day. And we actually have worked with a company who's doing wall paints. Again, not saying the name here, but you can imagine painting this room here with our smart wall paint and using the ceiling projector that we actually already have here, maybe with some rotation. So if you have an event, we can write different things on the walls or recolor the event space. So I showed you examples. Let me tell you a bit about the big vision behind it, and then I will go a bit more into the tech details of how does it actually work. So if you think about a lot of product design business or like product business, they're still analog, right? Let's say if you have a shoe company, right, they would make their money from the actual physical shoe. Yeah, so let's say random example, you have like New Balance here in Boston, right? If you actually talk to them, right, they would tell you, oh, you know, for the shoe, we will charge you like $200, right? And that's how they will make the money. So I actually think that in the future, maybe you will actually get your shoe for free. Yeah, maybe you get it in the mail as an advertising. Yeah, it's going to be a blank white shoe, there's nothing on it, and you get it for free. And how they will make the money is they will have an app. Yeah, and the app, you will download it on the internet and will be something like Netflix or Spotify, right? You will pay a certain amount of money per month, and you will get some free patterns with this subscription. And maybe if you want to be extra fancy, you want to look extra cool and get the really fancy skins for your phone or for your shoe, you will have to pay some extra. So I do think that in the future, like all the analog business that are like shoes or clothing or anything, maybe they will give you physical stuff for free and you pay for the subscription to the app. All right, this is what I just told you. So now we have this out of the way to give some background. I will tell you a little bit how it works on a technical basis, and obviously there's a lot more to it. But since we try to catch up on some time because of the fire alarm, I will keep it quick. So the main material behind our technology is something some of you might even have heard about. They're called photochromic dyes, and they are light activated. So by default, they are transparent. If you shine some UV light on it, they go from transparent to being colored. Then you can actually use them in your environment. And if you shine some, I call it here like visible lights, like RGB light in a focused way, they will go back to transparent. And they are called photochromic because photo is light and chromic is color, so it's color change based on light. So these photochromic dyes, you can actually just buy them. Yeah, so we buy them from a company in Japan, but the limitation here is that normally they are only a single color. So you can buy something that is transparent to cyan, you can buy something that's transparent to magenta or transparent to yellow. But obviously, if you just sprayed one of those things onto an object and then shine some light, you would only get different different levels of, let's say, cyan or different levels of magenta, but not a multicolor texture. So our big contribution here is figuring out how we can actually do a multicolor texture with different colors in it. So, and the basic idea is actually very simple. The smarts are a little bit more in the algorithm and technology in the end. So we buy cyan, magenta, and yellow, or the closest approximation we can buy on the market at the moment. And we mix them together, and actually you get something the same way as you've noticed from like inkjet printing, right? You have cyan, magenta, and yellow in your printer, and when you print them together, you get black. Yeah, that's actually the same here. That is matching the color model you would expect. So now we have this one bottle here with black, and that actually contains all the colors. Now the question is, how can we actually get the different colors out of this black bottle when we want to see something? So this is not yet the solution, but just to hammer this point home, this is the same bottle with the same liquid in all the images. Yeah, and the trick we are doing is, if you think about this bottle contains cyan, magenta, and yellow dye, and if you want to go from black to red, what we have to basically figure out is, how can we make the cyan dye in the bottle transparent? Because the moment that cyan dye is transparent to the eye, all your eye still sees is magenta and yellow, and you get the red bottle, which is the next image. If you wanted to get green, we would have to somehow figure out how to make the magenta dye in this liquid transparent, so you have cyan and yellow visible, and you get green, and so on. So now the magic question is, how do we make a single color channel, a single dye transparent? And this is where it gets like a little more into optics business here. I hope you can still follow me. The bottom has the wavelengths of light. And then the y-axis has how well the dye absorbs that wavelength. And basically, the moment they absorb that wavelength, they go from color to transparent. So for instance, if you wanted to make cyan transparent, only cyan transparent, we would need some sort of light source that shines, let's say, 335 nanometers roughly. So for magenta and yellow, we could choose something like this. You see, it is not ideal. Yeah? In a perfect world, we would work with material science engineers that would craft us some dyes who have like perfectly separated absorption spectra. That is not the reality at the moment, because nobody had really looked at this problem yet. So for the other light sources, we chose these. You see they have a little bit of overlap, which means if you shine 490 in the middle there, we also deactivate the cyan a little bit while we deactivate the magenta, so we can't get the full color space at the moment because of these material limitations. So funny enough, if you use a normal office projector, like the one on the ceiling there, they actually, lucky for us, have wavelengths almost exactly where we need them. So if you take an office projector, like this one, you open it up, it has a red, green, and blue LED in there. And if you actually plot the wavelengths of those red, green, blue LEDs, you see they are exactly there where we actually need them. For the green light, we had to add like an extra filter to squeeze, like to cut out some of the wavelength spectrum, make it more focused, but apart from that, it's pretty good. So literally what you saw in the videos before is this die that we have painted on an object and then literally just put in front of a projector like we have on the ceiling there. And you will see how we shine red, green, and blue light in different amounts to go from black down to some specific target color by selectively deactivating cyan, magenta, and yellow for each of the pixels to a certain level. So if you look at this video one more time, you see how the dark blue areas are done earlier in the middle, because going from black to dark blue needs less light shown on the object than if you need like a brighter yellow or something, then we have to deactivate more, so it just takes a little bit longer. So there is some fancy math behind it, and I'm not going too much into detail. The bottom line is, you see this at the bottom, X is black, so it's like full CMY, we call it 111 here, and then we just subtract the time it takes for red, for cyan, green, and magenta to deactivate by shining red, green, and blue light. All right, so popping up a level, like how can we make this better in the future, still takes some time. So we did some initial tests. We are not fully done with the experimentation. If you shine more light, it goes faster. So that is good news, yeah? So every projector has some sort of light source. If you blow on more light, yeah, we get a cinema projector or something more expensive. There's some hope this will actually be faster. So we did a little test here with twice the light, and it seemed to be doubling, but I'm be careful with any optics and material science claims. We have to really do the testing there to see if that's right. We did a different version that actually starts from a blank texture and only uses UV light to saturate. So it starts with transparency and saturates up to black, and that is actually much, much faster. Again, for reasons I'm happy to give you the paper if you're interested. So here you, for instance, see how we will shine UV light for 60 seconds, and that will already give you this preview texture. Let's say the product designer just wants to test something real quick. We can get that in roughly 60 seconds. So this is done now, and you can take it out and do some, look at it and be like, hey, I want it bigger, smaller, or whatever your choice is. Okay, here's a little bit more future work, stuff we are exploring. So this is our current setup. We have the UV light is to go from transparent to black. So once that is fully done, everything is black, then we use the normal projector to like go down pixel-wise to get the target colors. And our object is normally on like a little rotating platform where it rotates around so we can color it from all the sides. So we are hoping to have some other setups for recoloring, right? Because in the end, you can use projectors, but that's not really variable or on the go. So the question is, how can we shine RGB light and UV light on a more like variable form factor or something that's more on the go? So this is a project that is still under submission, so not yet published. But we basically built our own light source that has RGB LEDs and UV LEDs in a more flexible form factor. And now we can actually use this. Yeah, you see it there. There are the LEDs. So you use some laser cutting for like conductive copper and stuff, and you can just like wrap it around something to recolor it. So you don't need a projector anymore. You can just like have this in your pocket, and when you want to recolor, you just wrap it around. And you're like, all good. And because it's a contact-based method, it is also faster than if you have a projector at a certain distance, because the light really is in direct contact with the die. So again, this is work in progress. This can definitely be made more high resolution if we actually did some proper PCB manufacturing and stuff, but this is just like in-house prototyping right now of this more like mobile form factor. So it's just my student, Winnie, doing all the LED soldering and cutting and layering and everything by herself. Another thing we are currently exploring is there's technology where you can actually now put electronics inside of fibers. So people have already shown this with like touch sensing and other things, but you could also put LEDs inside a fiber. So this is obviously not yet a perfect fiber, right? But you see a rough fiber form factor, and we have LEDs inside, and we have our coating on the outside with the photochromics. So now let's say if this was actually woven into some piece of clothing, we could just turn on the LEDs, reprogram your clothing, and then turn it off, and you would be able to walk around with your new color pattern. It's a little bit like e-ink. You apply an activation source once, and then you get the color for a while. And we have also done this with trying to mix this into 3D printing. So if you are an expert in resin 3D printing, you know the limitation that you can typically only have one material in the tank. If you actually mix our material in there, we can have like a multicolor resin. So we can now have multicolor resin 3D printing, where on the left side you see this is MIT logo printed with just a single material by integrating UV projection and RGB projection into a custom 3D printer layout. All right, so I'm going to wrap this up. Yeah, our main motivation really is digital already has lots of easy things going. In physical, a lot of stuff is still hard. Can we make this better in physical to be more like the digital environment? And I showed you this as one example of the things we do in the lab. And yeah, if you have any questions later, I'm happy to chat more. That's it from me.